So if you were doing the math on that and heard the 30 plus years of experience in the industry, and you do the math, there's that 2% on the demographics that Tibor was showing early on. I'm in that group. So hey, I wanted to take, we've heard some really interesting stories today in artificial intelligence and machine learning, starting off with Tariq's presentation. My approach on this is going to be a little bit more near term. So the journey that I'm going to take you through today is almost kind of like a case study, kind of what we've been doing at DellEMC with what we're calling our smart assistants. So first thing that I'm going to do is I want to make sure to start off with context. Just like Gwen was talking about in some of her presentations, context is everything, because the different organizations we operate in are vastly different from one another. And then, so I'm going to give you the context of our DellEMC server business, which I'm the test architect in. Then I'm going to take you through a little bit of an overview of data analytics, which is another form of data-informed testing. I'm going to take you through that. Then I'm going to take you through the journey of how we started looking at and evaluating this as an opportunity space to do our testing more effectively. Then I'm going to go through the specific actions that we took. And what steps did we take? What problems were we trying to solve? How did we figure out what problems that we wanted to solve? And then wrap up with just some recommendations for you if you want to start going down this path. So the context at DellEMC servers is we're testing the servers that go into the data center. And those servers are very physical, right? It's got all these components that go into our servers. It's got the different CPUs, it's got the network interface cards, it's got the hard drives that go into the servers. And if you start thinking about what the different test configurations, when you start looking at all those multiples of the multiple vendors and then the multiple products that each vendor could provide, our test configuration matrix gets really big really fast. And it gets so big that we got our data scientists to help us actually calculate some of the numbers. And it was 465 trillion unique configurations that we could have tested in the last generation of servers that we were developing. 465 trillion unique configurations. So that's how many possible test configurations that we could have done. And that explained a lot of sleepless nights for our test leads as they were trying to figure out which ones that we were trying to do. But this is an example of just one of the test tasks, right? Not all of our test tasks are about executing tests. If you think about the different tasks that we do in the daily lives of our test, of our test engineering, it's not all about testing. There's a lot of test planning. This just happens to be a test planning activity. I'm going to take you through a couple of other ones, a couple of other tasks that we identified that are really deep think tasks. They're cognitive in nature, and they take a lot of our time. And if we can take a lot of that time and apply a smart assistant to it to do some of the other activities, like exploratory testing, then we've bought some more time back into our day. So this just kind of gives you a quick evolution of what our journey has been. If you take a look up at the top left, we started building servers at DellEMC in 1997. I joined there the next year, and I was in the development organization, and so we were doing waterfall. I had been doing waterfall up until 2010, along with the rest of the organization. That was when we converted over to Agile. So when we converted over to Agile, that's when we realized, wow, we've got to do testing a little bit differently. We get to partner with the engineering teams, the dev teams. And we also need to start automating a lot more. So we started automating, we started reskilling our test engineers to build up some of that programming and scripting skill sets. We then moved into a DevOps, where we started going into continuous testing, which was a natural progression. We started taking some of the skill sets of our testers and automating some of the other tasks that we do in our test job, which was setting up the test environments, deploying the software and automating those. We had a skill set to do that now. So going back to the end of 2016, I came across the World Quality Report, which just came out last month. That comes out every year. Capgemini Sogeti puts it out. And in that particular journal, that year they talked about something they called predictive QA. And the interesting thing about that was they were talking about automating tasks that you typically wouldn't think about as automating, cognitive-based tasks that we do. And so I started looking at, well, what's kind of as a test architect, I get to look ahead and see what we want to do next. And so I started looking at opportunities that we could automate other parts of our testing with that were cognitive in nature, that required a lot of data, that our users used, our engineers used a lot of data. And so we started our cognitive automation journey, and that's kind of what we called it. So this is, I call this one this is the analytics continuum that we started looking at. And again, as I mentioned earlier, we started at the left side and have been working our way up. Most anybody that's been that's collecting defects and collecting test case, doing a test case management tool, they're probably already doing a lot of reporting and starting to correlate and doing Pareto charts where they collect their data and they use their data to inform what they're going to do next. To go up to the next phase, when you get into predictive and prescriptive, that's a little bit more involved. Tariq was talking about earlier where the machines build their own model of their environment. This one is different. This is where we build the model of our testing environment, of the tasks that we're going to go automate through a cognitive automation. In predictive, I'm going to describe in a minute. Once you do predictive, you can do prescriptive, and you can automate the action that you want to take on the recommendations provided by the predictive model. Anybody that's had their credit card compromised, I had mine compromised just last week. Those companies are using predictive modeling and they're using prescriptive because they sent me the notification and the new card in the mail. That's a prescriptive way. When you start moving out to the right side of the chart, that's when you start getting into artificial intelligence and machine learning. Bottom line is, on all of these, they require data. All of this activity is based on collecting and managing your data. So in a data analytics model, it really comes down to you're building an analytics engine. And how do you build that analytics engine? Well, you need a data scientist, first of all, to help construct that. We've talked a lot about domain expertise and domain knowledge. That's our test engineers, because those are the folks that know our application, they know our environment, they know the history of what we've been doing. And we're trying to take and create that magic box that gives a prediction and a recommendation by taking that information and putting it into a model. Once you've got that model, then you start feeding in some of your operational data into that model to give you those insights, predictions, and recommendations. Important piece on this is, because this is that programmed model, that you need to feed all of the answers and recommendations that are coming back out of that do need to be sanity checked with the domain experts. You do want to be verifying that the model is giving correct recommendations and providing deep insights. So what goes into that model? Well, all of us that have been doing test engineering, we already have our best practices baked in. We've already got our rules of thumbs that we use. We've got the common sense and the positive and negative patterns that we've learned over our testing experience. Those are the sorts of things that we then, the way we program that into the model is we build up rules. We give weightings to those rules. That becomes our programmed model that we set up, and we continually refine by using the data and then getting it fed back in, and the domain experts, our test engineers that are using the recommendations, we go in and tweak the model. So this is how we then build that model. And it is all about the data. This is one of the most interesting things that I've learned about this, because a lot of the folks out there that are really selling us AI-based solutions, and there has been a ton of them pop up this year, they really understate the importance of data. And it's not surprising, because it is a boring, mundane job to clean up the data and keep it clean, because the typical part of keeping the data clean requires process changes. Who likes process changes? Those are tough, right? But it really is required to curate the data and keep that data clean. And one of the guys that, Brian Sletton, one of the TensorFlow presentations that I watched of his, I thought he did a really good job of depicting it, because no one goes out of their way talking about the sweeping and mopping involved of AI, because that's what happens with data. You have to keep it clean all the time before you get to the fun stuff of working with the model and then using the results and getting insights from the model. So what kind of data are we talking about? When you take a look at your defect tracking system, if you're using defect tracking systems and test case management systems, the source control management system, that's a great source of data. Your test execution history, the logs that you're hopefully capturing, or at least are getting created as you're doing your testing, that all represents a source of data that you can feed into models, and you can feed into machine learning models as well. Now this is a big enough screen where it's probably legible. This is a really helpful chart that I used early on, because what it does is it does a good job of identifying what of your data, what's an example of structured data and unstructured data. So structured data is your defects and your test cases that you're storing in a database. Your unstructured data is your logs, system logs, error logs. And the point here is that data that you own, in my case, the test case management system and the defect systems are the ones that we have a lot of influence and authority over. That is structured is much easier to begin working with and starting to derive insights out of. So structured data that you own. The reason I point that out is because we use this to help us identify what to pilot first. What did we want to go pilot and try and get some quick wins on first? The other parts on this that I wanted to call out is on the right-hand side, you'll see the engineering repositories, where you can kind of just rattle off the source control management, build management environments, your test case management, your defect systems. On the left, that's the interesting one for those of you that are working on websites or software as a service. You've got direct access to customer usage of your application. That's a gold mine of data, a really big gold mine of data. For us, it's easier for us to get at our manufacturing data. So like, what data did we sell to customers and which data did we actually build for customers? We're trying to work on getting access to what configurations our customers are actually using, because like I said, that's gold. But this is a good way for you to take a look at when you start identifying what problems you want to go after, what data do you need to support it. So that's what we did. So starting with that framework, the next thing that we did, and really one of the most important steps, is we needed to identify what were our biggest pain points. Because if you think, oh, that's a really cool thing, let's go off and do it, let's create a model, or let's go do machine learning, and you don't have an idea of what your prioritized pain points are, somebody else is going to dictate what they are. And so what we did is we got together 6 of our test leads, 3 of them in Bangalore, 2 in the US, and 1 of them in Taipei. And what we did is we started brainstorming. And Tariq talked about it earlier. What if we had this magic box? We don't know what happens in the magic box, but what if we had this magic answer box that we could go in and put at any one of our tasks? What tasks would they be? What questions would we want answered? We went and brainstormed for a couple of weeks with this, let people kind of noodle on it, try and get their heads around this. And we came back, synthesized that, prioritized that list into 47 questions that we then prioritized, and then laid out for each question, what data sets do we use to go answer those questions? We then knew what our prioritized list was. And so what we did is we popped those up. And if you take a look up at the top left, that's our 465 trillion unique configurations. What are the high value test configurations that if I had to go do some testing right now, what would they be? In the middle, anybody that's been doing automation would really love to know what test cases are really valuable to me, and I should spend the time refactoring them or retire them. Maybe I just retire them and I don't spend that effort and I spend the effort elsewhere. The one on the lower left gets into tying into source control management. What if I tied in and could detect the changes coming in, what test suites, what regression test suites would be optimal to hit this? Because one of the things that we found out about this is we've got a power now, that whole risk management piece, we've got a power to understand what not to test, which is pretty powerful. And not what a lot of people want to hear, but it's data informed. The next thing we needed to do is we didn't have data scientists on our team, so we needed to identify a data science partner. The first thing I went to is back to Capgemini because I read their world quality report. I figured they knew somebody that knew this area. So we contacted them. In the process of doing that though, I also read an article in the in the India Times. And they were interviewing a guy from Dell. Now remember, I'd been there for 20 years at that time. And they were interviewing a guy from Dell who was the performance analytics person. He headed up the group that did data analytics at Dell. And he had a team of about 700 people at the time. I mean, this happens in big companies and it's kind of embarrassing sometimes. But I found out about this organization through there. I was one phone call away from somebody that worked in that organization, got them in. So, and they had knowledge, but they had never worked with anybody in the engineering organization. They'd been working with the fraud department, they'd been working with the margins and the sales guys. Even on the website, they hadn't been working with anybody in engineering, so we were the first ones there. So we ended up picking both of them. And what we did, the interesting thing about it is when we talked to the folks in the performance analytics group, the Dell badged folks, they owned our sales data. They were the ones that knew who did we sell, what configurations did we sell. So they also went back and looked at how many did we sell. When we were looking at that prior generation and came up with 465 trillion unique configs, they went back and looked at our sales data and said, we sold 500,000 unique configurations. That was kind of sort of a mixed thing because 500,000 is still a lot, but it's a lot less than 465 trillion. But these folks owned that. So we ended up partnering with these guys. They helped us build this model that decomposed this, and we fire off multiple algorithms against the database. This is our Q Smart Assistant, and Q helps us narrow down the top 300 to 500 configurations per new platform that we're releasing. This saves us about 2 to 3 weeks worth of effort of our test leads time during the planning part of this. But where this is really going to help us out is when we're in the last stages of testing, the last 10 weeks of testing of our servers, and we don't get pieces and parts in time. What's the next best configs? Jarvis is our next smart assistant. So this is based off our Iron Man, off of Iron Man, obviously. It's Iron Man's smart assistant. This is the one that helped us identify the top configuration, or the top test cases and test suites to use. And it's the smart assistant that helps us identify which ones are going to identify the break fix, if I'm over testing or under testing, which ones do I not test. So this is the second one. This is the one that we partnered with Capgemini. And then as Tariq talked about, he talked about some of the new UI automation tools that are coming out that we're referring to them as AI-assisted UI automation. Mabel, Test.ai. Again, what these ones are doing is these ones have they've trained all their bots on applications in the public domain, so they know how to walk applications, mobile apps. But they do coverage, and they give you deltas between what happened on your last release and this release. Really helpful. Not something that we're going after yet, but we did do some experiments with them in the summertime. So, to wrap things up, I encourage you. Hopefully, you've been spurred to start some of your own experiments with AI or analytics during this one. Capture your data, because it is all about your data. So start capturing your data, even if you're not going to do it. Most importantly, pinpoint your pain points before you go in and engage with outside help to go do your solution. Rethink how what your testing tasks are. Reimagine your testing to go use techniques like this and apply a cognitive automation. And then lastly, don't be afraid to partner with the machine. Thank you.
Thank you very much. I would just like to remind you to vote for your favorite speaker, because I heard there were prizes for that, and also to ask all of your questions through Slido so that we can address them to our speakers. And now let's see what we have as questions.
And in the proceedings, there's a bunch of resources that I've got in the backup of the deck too.
Any questions on Slido? We can't see them. Okay, anyone from the audience wants to ask a question? And please be very loud. Yes, please.
Did you look into orthogonal arrays or pairwise when selecting all these server combinations?
Yeah, so the question was, did you look into any other techniques in selecting configurations like pairwise techniques? And we have been doing pairwise techniques for probably the last 7 to 8 years. So, but yeah, that's another example.
You do find it useful?
If you find it useful.
Oh yeah, no, we absolutely did. We absolutely did find pairwise testing useful. When we started going on this path, the same guys that had been using pairwise testing were looking at this, and they got really excited once they understood what this could do even further.
Okay. Any other questions? Please.
What's that? No, we did not tackle all of our pain points. So we had a list of 47. We tackled the first 2, did a pilot. So we piloted those last year. We just finished our implementation on each of those and deployed these this month. So now we're going to go back and revisit. We've already got a couple more that we're going to plan, like the source control management. We're going to tie that in. And we're going to go back and revisit the prioritization to see, because we've learned so much more about it, and see if the priorities have changed. But we're tackling the source control management stuff next.
And a very good question that we have here is, how long does it take to create a smart assistant?
That's a really good question. It does all depend on resources, right? What we did is, we've got a very big continuous improvement culture. And so last year, in 2017, what we did is we assigned part-time subject matter experts, and then we got in the external data scientists to come help us build it. And we piloted that over the course of the year, built it, identified what the data gaps were, went in. We didn't do it production level, but we did prove it so that we could get good results out of it. This year, when we started at the beginning of January of this year, we had 2 data scientists on each of the smart assistants, and then we had subject matter experts assigned to them, and it took us about 9 months to develop it and then get all the data curation and processes in place.
Okay, we don't have any more time for questions, like maybe a very short one. had any troubles of getting detailed sales data for your products to engineering, like confidentiality issues? If yes, how to overcome them?
Yeah, no, that's a great question. We didn't have problems getting the sales information, really because the data scientists that we had brought in from our performance analytics group, they owned that sales data, and they actually knew how to get in the nooks and crannies of the sales data to get it for us. So that worked out really good for us.
Okay, thank you very much, Geoff, for your talk.
Thanks, Corinna.
All right.
All right, thank you.